All right, this is the video for area and circumference of circles, one of my favorite topics. Let's get into it. The first thing, you need a little bit of background information before we do these problems. So first things first, R. You need to know what R is when we put it in a formula and we're talking about circles. R stands for radius. R is radius. Now, the radius is the distance from the center of the circle to the edge, and it can be in any direction. So if it goes from the center of the circle to anywhere on the edge of the circle, that distance is the radius of the circle. And when we do formulas, we write R for the radius. So the radius is the distance from the center to the edge of the circle. You need to know that. Now, this right here, it says radii. What is that? That's the word radii, and that's the plural of radius. So you have one radius, but you have two radii. So we don't say radiuses, we say radii. So that's the plural of radius. The next thing you need to know is the diameter. Now, if we have a diameter in a formula, we just use the letter D. The diameter is the distance from one side of the circle to the other going through the center. So the longest distance from one side of the circle to the other is the diameter, okay? The diameter is the distance from one side of the circle through the center to the other side of the circle. Now, you might notice that the radius goes from the center to one edge. So if I put one radius going from the center to one edge, and then I go back to the center and put another radius going the exact opposite direction, that's a diameter. Take a look at the diagram for diameter. Go from the center of the circle in one direction, that's a radius. Go in the other direction, that's another radius. So that leads you to the following conclusions. One radius is half the diameter. So you can say the radius is equal to the diameter divided by 2. You're also allowed to say 1/2 times the diameter. Those mean the same thing. The diameter divided by 2 and 1/2 times the diameter gets you the same thing, and the radius is the diameter divided in half. Or if you have the diameter, you can say that the diameter is 2 times the radius. So one diameter is 2 times the radius. So diameter equals 2r. So those are the formulas you need. And you can use, well, those aren't the formulas. Those are the radius and diameter definitions you need. And if you have those, now you're ready for the formulas that you are going to use for these problems. And the formulas you are going to use are for circumference and area. So let's start with circumference first. Circumference is the perimeter of the circle. So the distance around the edge of the circle, we call that the circumference, and we usually just mark that with a big C. Okay, so a big capital C. If I start at one point on the edge of the circle and I travel all the way around the circle, that distance I traveled is the circumference, okay? So the perimeter of the circle, the distance around the edge of the circle, if you travel the whole distance around it, whatever that length is, that's a distance, that's the circumference. And the formula for the circumference is this. The circumference equals 2 times pi times the radius. So 2 pi r, 2 times pi times the radius. The order of the letters doesn't matter. This is the way we write it because of math grammar. But if you wrote it like this, if you wrote 2 times r times pi, that's the same thing. Okay, it doesn't matter the order that you multiply stuff in, right? When you multiply things, the order doesn't matter. So if you have 2 times pi times r, 2 times r times pi, it's the same thing. Now, why would I write it differently? Why would I do that? Because you already know that the diameter is equal to 2 times the radius. If I write it this way, it's real easy to see, hey, there's a 2 times the radius right there, isn't there? So another way that people write the circumference of a circle is diameter times pi, because 2 times the radius is the diameter. So if you have the diameter, you just multiply that by pi. Now you might be asking yourself, well, wait a minute, what in the heck is pi? If you are not familiar with pi, then that's going to be real confusing, but it's okay. I'm going to make it real easy for you. Here it is. Pi is what you get when you take any circle's circumference and divide it by its diameter. Anytime that you take any circle of any size, it doesn't matter how big or how small the circle is. The circle could be, the circumference of a hydrogen atom, or it could be the circumference of the observable universe, anywhere in between. The smallest thing that you can find or the largest thing you can find, whatever it is, if you take the circumference of that circle and divide it by the diameter of that circle, you always end up getting the same thing. And that number that you always end up getting is 3.1415, and I think it's a 9265, and you know what? It just keeps going and going and going forever. There's no pattern to the decimals after this point. I mean, we know what a lot of them are. Computers can calculate it to, billions and billions of digits, but we don't have a pattern ever. There's no repetition and there's no ending. The decimals just keep on going and going and going. So because of that, it's a really, really hard number to write. We can't write it as a fraction. And so the decimal's like super, super long. So instead of writing out all these decimals all the time, we just write this little symbol pi. And this little symbol is actually a Greek letter. It's part of the Greek alphabet. So it looks like a little table or something, but it's the Greek alphabet letter pi. And the way you spell pi is P-I. There's no E, not like the food. The food is P-I-E, but the Greek letter is just P-I. So in Study Island, a lot of times elsewhere, when people say pi, they just round. They don't use the exact thing because it takes forever. There's a decimal. It keeps on going up forever and forever and forever. So a lot of times in your lesson, you're going to be told to just say that pi is a 3.14. We usually can say that that's close enough for most things that we want to do. So pi is about 3.14. So you're going to see this a lot in Study Island. It's going to tell you to just use 3.14 in your calculations when you're using pi. All right, so if I ask you to calculate the circumference of a circle, and I tell you that the radius of the circle is, let's say, 5, and I say, hey, what's the circumference? All you have to do is plug 5 into the formula. So let's do that. The circumference is equal to 2 times pi times the radius. So the circumference is equal to 2 times pi, and we know the radius is 5. So instead of r, we can write 5. Okay? Now, the order doesn't matter. 2 times pi times 5 is the same as 2 times 5 times pi. So what's 2 times 5? 10. So I can say circumference equals 2 times 5, 10 times pi. And if I was told to just use 3.14 for pi, now I can just multiply 3.14 times 10, and I get circumference equals 31.4. And if this 5 originally was inches, this circumference is still in inches. It's a distance, so it's in the same units as the radius. And that would be it. That's all you have to do. Now, there is one little thing. You might be given the circumference and asked to go backwards. So let's say you were given a circumference of a circle, and they told you the circumference of the circle was 628 meters, let's say. They told you it's 628 meters. Well, you know the circumference is always 2 times pi times the radius. So what you can do is you can say, okay, well, how about I say that 628 is equal to 2 times pi times the radius. Now, the circumference is 2 times pi times r, and you know the circumference is 628, so you can replace the circumference, the c, in the formula with 628. Okay? So now all I have to do is solve for r. Well, I can divide by pi on both sides. Okay, so if I divide by pi, and you can use a calculator, you're going to end up using a calculator a lot when you do these problems. So here's a calculator. I'm going to do 628 divided by, oh, and hey, you know what? You see this little button, this pi button? That'll actually put in pi, like the real value. But we're not going to do that for now because it says to use 3.14 for pi for most of these. So I'm going to divide by 3.14. But if you wanted to be more specific, you could use the pi button if you wanted to be even more accurate. So when I do that, I get exactly 200. So 200 is equal to 2 times the radius. And now if I divide both sides by 2, 200 divided by 2 is 100. So that equals the radius. And because this was in meters, I would say the radius equals 100 meters. So there you go. So that's how you do those problems with circumference. If you are given the radius, just plug it into the circumference formula. You're going to end up doubling the radius. If they give you the diameter, you're all set. You just multiply the diameter by pi. But if they give you the radius, multiply the radius by 2 and then multiply that by pi, or 3.14 normally. But if they give you the circumference, you have to do that backwards. You have to divide by pi, and then you'll have the diameter. So 200 was 2 times the radius, and remember 2 times the radius is the diameter. So the diameter of the circle was 200. And then we divided that in half to get the radius, which is 100. So that is circumference. The other thing you need to know is the area formula. Now, area is a term you should be familiar with because you've been calculating area of shapes for a long time. You know how to calculate the area of a rectangle and a triangle, hopefully. So the area, we just marked that with a big A. The area, how much space the circle takes up, is going to be equal to pi times the radius squared. If you want to write the radius squared times pi, that means the same thing. We usually write pi times the radius squared because pi is a constant and r is a variable, and we usually put the constants in front of the variables, but whatever, these are the same thing. So pi times the radius squared, or radius squared times pi. So what's the area of the circle that we started with over here, the one with the 5? What were the 5 inches over there? What is the area if the radius is 5 inches? All we have to do is plug r equals 5 into the area formula. So here we go. Area equals pi times 5 squared. Now, you always have to do exponents first in the order of operations. So we're not going to do pi times 5 yet. We have to do 5 times 5. We have to do 5 squared. Remember, squared means times itself. So pi times r, okay? So this means pi times 5 because 5 times 5 is 5 squared. So that's 25. So the area equals pi times 25. And so all you have to do is go over to your calculator and say, all right, well, what is pi times 25? 3.14 is pi times 25 equals, and you get 78.5 if you're using 3.14. So 78.5. Now, something very important to pay attention to here. What are the units of measurement? It's area. And when you calculate area, you calculate it in square inches, not regular inches. So the answer here would be 78.5 square inches. Square inches. Okay? Let's go backwards. What if I told you the area and made you tell me the radius? What if you were asked to go backwards? Okay, well, how about if I told you the area of a circle was, let's just make this one super simple. Let's make it 314, and I'll say square centimeters. Okay, so let's remember the area is equal to pi times the radius squared, right? So if I know the area is 314, I can say 314 equals pi times the radius squared. So what do I do to figure out my radius? Well, first I divide by pi. Okay? And if pi is 3.14, 314 divided by 3.14 would give you 100. So 100 equals r squared. Then I want the square root of r squared. So I take the square root of 100, and that's equal to the square root of r squared. The square root of something squared gives it right back to you. Those are opposite operations. So if you just want r, and you know r squared, you take the square root of r squared. Anything you do to one side, do it to the other. The square root of 100 is 10. So there's your radius 10. So the radius is 10. And since the area was in square centimeters, the radius is just in regular centimeters. So that's it. Those are all the main things you need to know to do these problems. We'll do some more examples here. Let's jump into them. Number 1. The circle above has a radius of 10 centimeters. What is the area of that circle? Okay, so we're going to use our area formula. The area formula is pi times the radius squared. We know the radius is 10. So I actually just did this. I just happened to do this exact example, but backwards. I gave you the area, and then we found the radius, but let's go the right way. If the radius is 10 centimeters, what is the area? Okay, here we go. The radius equals 10 centimeters. The area is equal to pi times the radius squared. So the area is equal to pi times 10 squared. So the area is equal to pi times 100. So if pi is 3.14, then the area equals 3.14 times 100. And so the area equals 314 square centimeters. Centimeters squared. Okay, because we started with regular centimeters, we get square centimeters now. So let's go back and see if 100 square centimeters, or 314 square centimeters is one of our answers, and there it is, 314 square centimeters. All right, next one, number 2. Jenna is planting 4 circular gardens. She's planting 1 garden each for tomatoes, carrots, cabbage, and strawberries. Each garden will have a fence around it to keep rabbits out. The tomato, carrot, and cabbage gardens will all be the same size. Since Jenna loves strawberries, the strawberry garden will be larger. It will use the same amount of fencing as the other three gardens combined. She used a total of about 113.04 feet of fencing material. And note up here, it says use 3.14 for pi. Now, this is a confusing question for your second question, but it's okay. I'm going to break it down for you. Don't worry. Here we go. We have 4 gardens. 3 of them are small and the same size. It says each garden will have a fence around it. The tomato, that's one garden. The carrot, that's another garden. And the cabbage, that's another garden. So those 3 gardens are all the same size. So the amount of fence that they use will be the same size. The amount of fence is the circumference. Okay, the amount of fence that each of these circular gardens needs is the circumference of the circle. So these 3 circles, okay, the tomato circle, the carrot circle, and the cabbage circle are all going to have the same circumference because they're all the same size. But the strawberry circle is going to be bigger. And it's going to use the same amount of fencing as the other 3 gardens combined. So whatever the tomato circle circumference plus the carrot circle circumference plus the cabbage circle circumference is going to equal the strawberry circumference, because the strawberry garden is those 3 combined together. All of those combined is a total of 113.04 feet of fencing material. So now, what do we want? We want the area of each smaller garden, the area of each smaller garden. We want the area of the larger garden, and we want the area of the larger garden is some amount of times larger than the area of the smaller garden. So when it talks about fencing, it's talking about circumference, but then all these questions are about the area. So what we have to do is we have to just figure out how big these circles are. Let's find the radii. Let's find the radius of each garden, okay? How do we do that? Here's how. Let's say the small garden circumference is x. If the circumference of the small gardens, and remember there's 3 of them, is x, we can write that x plus x plus x is the circumference of all 3 gardens, of all 3 small gardens added together. If I add 3x to that, that's the strawberry fence. Okay, so here's tomato, here's cabbage, and here's whatever the other one was, those 3 small gardens. I forget what the thing was. Okay, so tomatoes, carrots, and cabbages. Each one of those was a small fence. So x is the circumference of the tomato fence, the circumference, or the tomato circle, that's how much fence it uses. X is the circumference of the tomato circle. It's also the circumference of the carrot circle. It's also the circumference of the cabbage circle. Well, what's 3x? That's the strawberry circle, because remember, the strawberry circle was all 3 of those combined. So here's the fence for tomato, here's the fence for the carrots, here's the fence for the cabbage, and here's the fence for the strawberry. All right? She said altogether they used 113.04 feet of fencing, I believe, 113.04. So if we add up all the fencing for all 4 gardens, it should be equal to 113.04 feet of fencing. So now we can solve this equation. 1x plus 1x plus 1x is 3x. 3x plus 3x is 6x. So 6x equals 113.04. If we divide both sides by 6, we're going to get the circumference of a small garden. So we have 113.04 divided by 6 equals, we get 18.84. So x equals 18.84. That is the circumference of a small garden. So what is the radius of a small garden? So here we go. Let's find the radius of a small garden. Radius of the small garden. Radius of small garden. The radius of the small garden, if the circumference is 18.84, and remember the circumference formula is 2 times pi times the radius, all we have to do is plug in the circumference and then solve for radius. So here we go. The circumference is 18.84. And that's equal to 2 times pi times the radius of the small garden. Divide both sides by pi. And again, we're using 3.14 for pi. 3.14 is what pi is according to the problem. So we have 18.84 divided by 3.14. And we get 6. That is then 2 times the radius. So 6 equals 2 times the radius. And then I divide both sides by 2. 6 divided by 2 is 3. So the radius of the small garden is 3. Okay, now if I want to put a unit of measurement on this, I just have to look back. They were using feet, so we're still using feet. So the answer is the radius of the small garden is 3 feet. Okay, small garden radius, 3 feet. Okay, so that's the small garden. Well, what about the strawberry garden, the really big one? What's that radius up there? Well, its circumference is 3 times the smaller one. So it's going to be 3 times 18.84. So when we divide by pi, we're going to get something 3 times as big, which is 18. And we divide that by 2, we're going to get 9. If you want me to write out the long way, that's no problem. Here it is. The large garden has 3 times the circumference of the small one. So the large strawberry garden is going to be 18.84. It's going to be times 3. Okay, so remember the circumference of the circumference of the strawberry garden is 3 times the circumference of one of the small ones, because the strawberry garden is all 3 of these put together. So if I said, what's the radius of the large garden? Okay, radius of the large garden. All we have to do is say, all right, the circumference of the large garden is 56.52. And that equals 2 times pi times the radius. So we divide both sides by pi. And again, we're using 3.14, so divide by 3.14. And we go ahead and we get 18, just like I said. So we're going to get 18 equals 2 times the radius. And we divide both sides by 2. 18 divided by 2 is 9. So the large garden has a radius of 9. Okay, so the radius of the large garden is 9 feet. Okay, so now that we know the radius of both gardens, the small garden and the large garden, we can finally find the areas that we need to look for. If I say, what's the area of small? Here we go. Let's do the area of a small garden. Area of the small garden. Remember, the area is equal to the pi times radius squared. The radius of the small garden is 3. So the area will equal pi times 3 squared. So the area will equal pi times 9. So the area is whatever 3.14 times 9 is. So we go to our calculator and we say, hey, calculator, what is 9 times 3.14? And we get 28.26. 28.26. And our original radius was in feet, so 28.26 is square feet. All right, now let's do the area of the large garden. Area of the large garden. Its radius was 9. So again, the area equals pi times the radius squared. So the area equals pi times 9 squared. So the area equals pi times 81. So the area equals whatever 81 times 3.14 is. So 3.14 times 81 equals 254.34. So 254.34. Okay. And again, that's square feet now. So now we have all the information we need. We've got the area of the large garden, the area of the small garden, and we can answer all those area questions. So let's go ahead and do that. All right, here we go. The area of each smaller garden is about how many square feet? Does it say to round to whatever? Nope. Let's just put in 28.26. So 28.26. The area of the large garden is about 254.34. And the area of the large garden is how many times larger the area of the smaller garden? That's a division problem. Now we can punch in 254.34 divided by 28.26, but take a look at something. Before we got to these numbers, what was the area of the small garden? Pi times 9. What was the area of the large garden? Pi times 81. How many times 81, or how many times 9, is 81? 9 times 9 is 81. So the large garden is 9 times larger. If you want proof of that, let's go ahead and divide those numbers. 254.34 divided by the small garden, 28.26. And look at that, you get 9. All right, so that's how you do that problem. One of the more intensive ones that you'll have to do. Most of these are much easier. Number 3, the length around the outside of semicircle C from point A to point D to point B is 37 inches. So it's 37 inches around the arc. From A through D to B is 37 inches. But the perimeter of semicircle C is 60.57 inches. So 37 inches from here all the way to B, but then when we go all the way back to A along this straight line, we get 60.57 total. So let me draw a quick little diagram so you can see what I'm doing for this. All right, so here I kind of copy the diagram down so I can draw. First, the 37 inches goes from point A down here all the way over to here. Okay, that distance, that is 37 inches. But if the whole perimeter is 60.57 inches, that means that this distance right here has to make up the rest. So all we have to do is say, in our calculators, 60.57 minus the 37, and we get 23.57. So on my diagram, that distance from A to B is that result that we just had in our calculator, which was 23.57. So we've got 23.57 inches from A straight to B. Well, if this was a full circle, then that would be the diameter. So the radius is half of that. So we just divide 23.57 in half, divide it by 2, and we'll get our radius. So divide by 2, and we get 11.785. So the diameter up there was 23.57, and the radius is 11.785 inches. Okay, well, it's a semicircle, but if it was a full circle, we could use the radius to calculate the area. The area is equal to pi times the radius squared, so the area is equal to pi times 11.785 squared. So let's go ahead and just punch that into the calculator, make it easy on ourselves. I've already got 11.785. And if you have this button on your calculator that says x squared, or some of them say n squared or something like that, it'll automatically square your number for you. That means it'll automatically multiply by itself. So watch, 11.785 and hit the square button. Boom. It says 138.886225. Now I'm going to go back 11.785. So this is where we were a second ago, and I hit the square button. But what if I put times 11.785? I got 138. I got the same thing. So again, if you have 11.785 in your calculator, or any number, and you just want to square it, you might find a square button on your calculator to do it faster. Okay, so there's the r squared part. Then I have to multiply by pi, right? I have to do that times pi, so times 3.14. And that would be the area of the entire circle. But we don't have a whole circle. We have a semicircle, which means we have half of a circle. So I'm going to take the area that we have, which is 436.10. Okay, we have 436.1027465. It's a ridiculous decimal. But a semicircle is only going to be half of that. So I'll divide it by 2. And that's the area of our semicircle, 218.05. So let's see if that's in our dropdown. 218.05 is right there. That's it. So again, they told us 37 was A to B, and they told us the whole thing was 60.57. So we did 60.587 minus the 37 to get the distance from A to B. That's the leftover part. That's the diameter. So we cut it in half to find the radius. Then we did radius squared times pi to get the area of the whole circle. But since it's a semicircle, we cut it in half, and that was our answer. Number 4. For the given circle, which of the following is true regarding its circumference and area? All right, remember the radius up here is 1 unit, it says. It says the radius is 1 unit. So 1 inch, 1 meter, 1 whatever, it's 1. A, the circumference is larger, and it's 2 times the area. Okay, well, let's find out what the circumference and the area is. If we're going to have to compare their measurements, we better figure out what they are. So let's go figure out the circumference and the area of a circle with a unit of 1 radius. Okay, so I just made a circle with a radius of 1 inch. This says 1 unit. It doesn't matter if it's 1 inch, 1 meter, whatever. The relationship between the circumference and the area will stay the same. Let's find the circumference. Again, the circumference is 2 times pi times the radius. So the circumference is 2 times pi times 1. No, well, that makes it easy because 2 times 1 is just 2. So the circumference is 2 times pi. I'm going to stop there. I'm going to stop there. Notice that our problem's not like use 3.14 for pi or anything like that, because we're going to compare the circumference to the area, and that's easier when we just leave the pi in. Okay, so I'm going to leave it as 2 pi for now. It's 2 pi inches, all right? What is the area? The area is equal to pi times the radius squared, so the area equals pi times 1 squared. Well, 1 squared is 1 times 1, which is 1. So the area equals pi times 1. So the area is just pi. So the area of this circle is pi square inches. So the circumference is 2 pi, and the area is 1 pi. So now what's true? What's larger, the circumference or the area? Assuming that, this is inches and this is square inches, but what number is larger, 2 pi or 1 pi? Clearly 2 pi is larger. So the circumference is larger. C and D say the area is larger. Those are wrong. So it's either A or B. The circumference is larger and it's 2 times the area, or the circumference is larger and it's 4 times the area. It literally says 2 pi to 1 pi. It's pi times 2. So it's 2 times the area. Area is 1 pi, double that, you get 2 pi. The circumference is larger, and it's 2 times the area. Okay. Next one, number 5. The diameter of the circle above is 30 inches. What is the circumference of the circle? So they told us the diameter. You get the circumference. Please, please, please remember I told you that you can find the circumference by just doing diameter times pi. Okay, you don't need any special, you don't need to write anything down for this problem. You don't need any special anything. The circumference of a circle is the diameter times pi. You might call it 2 times the radius times pi, or pi times the radius, or 2 times pi times the radius. But one of the things you can do is just take the diameter and multiply by pi, and you get the circumference. All the problems you do, you got to be able to do this one the easiest. If they tell you the diameter, just multiply by pi, and you get the circumference. If you take nothing else away from doing all these, please take that. The diameter times pi is the circumference. So here we go. 30 times pi, which is 3.14 for this problem. It tells us to use 3.14, is equal to 94.2. That's the answer. Simple, easy, no problem. Next up. Number 6, a circle can be cut into smaller and smaller slices and rearranged in the shape of a parallelogram as shown. So they're cutting the circle up so it looks like that. Now this is it's kind of hard to watch, like seeing a still picture. So let me show you an animation of this. So I did a quick Google search for a area of a circle animation. And by the way, there's 1,000 things online for circumference and area. So if what I'm showing you is too confusing, you don't get it, you can look up 1,000 other resources, not just the Study Island lesson, which has plenty of stuff and 5 pages of materials, but there's YouTube videos and everything. So look for stuff out there. Here's an animation of how we get from this circle to this weird thing they're calling a parallelogram. And a lot of this stuff comes from medium.com. Here's an animation. If you cut a circle into slices and rearrange those slices, it looks like a parallelogram. Now you might be thinking to yourself, that's not a parallelogram. The tops are curved because they were arcs of circles. And you're right. But if you make the slices even smaller, then that arc becomes less pronounced. Watch. Here we go. There's the bigger pieces, but if you cut them into smaller pieces, you see how the little arc on the top is like not there as much. It's a lot smaller. It's a lot more like a straight line along the top than it was before. And here it's going even smaller pieces. Imagine cutting them all into these tiny, tiny little slices, separating them out, and then combining them together. That looks a lot like a rectangle or a parallelogram to me. So if you take a circle and you cut it up and you make it look like a parallelogram, you get what this problem is asking you about, okay? So here we go. The formula for finding area, A, of a parallelogram with base B and height H is shown below. So the area of a parallelogram is base times height. The base is the distance along the bottom, and the height is the distance from the bottom to the top. Which equation represents the circumference of the circle in terms of its area? So you notice that the little light blue highlights go along the top and along the bottom. And that same light blue highlight is along the circumference of the circle. When you take a look at the diagrams, you can see that the circumference of the circle becomes the top and the bottom. Now, half of it goes along the top, and half of it goes along the bottom. So half the circumference is the base of the parallelogram. So the circle gets cut up and half of the circumference goes along the top and the other half of the circumference goes along the bottom. Again, you can kind of see it in these animations. Watch half the outside of the circle goes to be like the top of it and the other half goes along the bottom. So the bottom is half the circumference and the top is half the circumference. Then what is the height? Well, the height is the radius, the distance from the center to the edge. Watch how the radius gets broken up and becomes that height right there. So the radius, the little lines, the length of these slices is the distance from the top to the bottom. Okay, so that distance from there to there, that's the radius. So when we go back, we see this. Which equation represents the circumference? Well, the area is equal to the base times the height. The circumference is equal to what? Well, we just said that the base is half the circumference, so replace A equals B times H with A equals the circumference divided by 2 times H times height. Here's what that'll look like if I'm doing it on paper. All right, so you have area equals base times height. I don't use the multiplication X because I like to save X for a variable. So base times height, I just write BH, base times height. But the base is, again, half the circumference. So if the base is equal to half the circumference, that's circumference divided by 2. So instead of base, I'm going to write circumference divided by 2. So the area equals the circumference divided by 2 times the height. So let's solve for C. Let's divide by the height on both sides. Divide by height, divide by height. So the area divided by the height is equal to the circumference divided by 2. Well, what if I still want to solve for circumference? I have to multiply by 2 on both sides. Cancels the 2 out. Do it to one side, do it to the other. So 2 times the area, because 2 times A, divided by the height is equal to the circumference. So which one says the circumference is 2 times the area divided by the height? Oh, let's not forget, the height was the radius. So I just replaced that H with an R. 2 times the area divided by the radius equals the circumference. And we get what we're looking for. All right. Next up. A wall clock has a circumference of 43.96 inches. What is the area of the clock? So they give us the circumference and they make us find the area. So we take the circumference, we find the radius, then we use the radius to find the area. So let's do this. All we have to do is say, all right, if the circumference is equal to 43.96, what's the formula for area for circumference that finds us the radius? And then how do we use the radius to find the area? All right, so here we go. The circumference is 43.96. So let's not forget the circumference is 2 times pi times the radius. So 2 times pi times the radius is equal to 43.96. Divide both sides by pi. 2 times the radius equals, get your calculator out. You get 43.96 divided by pi, which we're using 3.14 because that's what the problem tells us to do. And we get 14. So 2 times the radius equals 14. Divide both sides by 2. The radius equals 7. If the radius is equal to 7, well, let's not forget that the area is equal to pi times the radius squared. So area equals pi times 7 squared. You should know that 7 times 7 is 49. So 7 squared is 49. We get pi times 49. So the area equals 3.14 times 49. 3.14, that's pi, times 49 equals 153.86. And there it is right there. Next up, Marcy is making a hooked circle-shaped rug. A hooked circle-shaped rug for her mother. The circumference of the circle-shaped rug is 69.08 inches. What is the area of the rug? We literally just did this problem. We just did it with different numbers. Take the area. Okay, we did the same thing. Let's just go back to the problem we just did. We took the circumference. Okay, the circumference there is 69.08. And the last one, it was 43.96. What did we do? We said that 2 pi r is equal to 69.08. Sorry about that, little glitch in the matrix there. So we took the circumference, and we said the circumference that they tell us has to be equal to 2 times pi times r. What did we do first? We divided both sides by pi to get, what's the diameter? 2 times the radius is the diameter, right? Then we divided that number by 2 to get the radius. Then we said the radius squared times pi is the area, and we got our answer. So let's just do that with this one. We don't even need to write it all down. We just got to follow those same steps. So here we go. Take the calculator. Here we go. We've got the circumference, 69.08. That is equal to 2 times pi times the radius. So we're going to divide by pi. Divide by 3.14. So 2 times the radius for this problem is 22. Our last problem, 2 times the radius was 14, but we just divided by pi and we got 22 this time. So the diameter of this rug is 22. The diameter of the last problem was 14. We divide the diameter by 2 to get the radius, so the radius of this rug is 11. The radius for our last one was 7. Well, what did we do? We took the radius and we put it into the formula for area, which is pi times the radius squared, which means we take the radius and we square it. Last time it was 7 times 7 is 49. This time it's 11 times 11, which is 121. And then finally, we say that times pi. So we say times 3.14, and we get our answer, 379.94. There's our answer right there. Number 9, Brandon drew 4 circles, each with a different diameter on a piece of paper. For each circle, he laid a piece of string along the outline. That's the circumference. And then measured the length of the string. His results are shown in the table below. So he's got diameter, 5 centimeters, length of string, 15.7, etc., etc., etc. Brandon wrote the equation y equals k times x to model the relationship between the circumference and the diameter of the circle. Which of the following statements correctly describes what k represents in this equation? 1. K represents the radius. Is that true? Do you take y equals k times x, where y is the length of string and x is the diameter, or even vice versa if you wanted to, would you multiply by the radius to get from one to the other? Ask yourself that question. Hopefully at this point you know the answer is no. The diameter times pi gets you the length of string. So k is not going to be the radius. K should be pi. Oh, hey, look what number 4 says. K represents pi. Well, there you go. Now, this also says k represents a unit rate. In this case, yes, the unit rate is pi. Anytime you have the equation y equals k times x, k is the unit rate for the problem. And when you're talking about a diameter and a circumference, the unit rate is pi. So you've got number 2 and number 4 as the correct ones. 2 and 4 only. And number 10, Rupert is copying some files from his computer to a compact disc like the one shown above. If the diameter of the compact disc is 120 millimeters, told you the diameter, what is the approximate area, ignoring the center hole? So we're going to calculate the whole area, pretend like there's no hole in the middle. Well, what do we do to find the area? We just take the radius and square it, and then multiply by pi, right? Well, if the diameter is 120, you need to remember that the radius is half the diameter. So your radius is 60. Okay, 120 divided by 2 gets you your radius. All right? I'll draw a diagram for you. All right, so here we go. I drew a circle that has a diameter of 120 millimeters, okay? Know that there's 10 millimeters in a centimeter, right? And I went from 0 all the way over here through the center to 12. Might not be able to see the ruler, but there's 10, 11, 12 goes right there. So that's 120 millimeters across. So if this entire thing, and here's the center of my circle, if this entire thing is 120 millimeters, if it's 120 from here all the way to there, that's 120. And that's the diameter, okay? So the diameter equals 120 millimeters. Then the radius, which goes from the center to the edge, has got to be 60 millimeters, okay? That's 60, and the other radius, That's 60 also. So the radius is 60 millimeters. The diameter is 120 millimeters. It's asking for the area. What's the approximate area? The area is equal to pi times the radius squared. So the area is equal to pi times 60 squared. So what is the area equal to? It's okay to use your calculator, folks. Here we go. You got 60 squared times 3.14, and we get 304 square millimeters. All right, that's it. That should be plenty. And again, you have lots of resources online. Don't forget to look through the lesson. There's videos here. There's also plenty of written examples for you to look through. It shows you the drawing things into slices problem again. So there's lots of stuff for you to get through on this particular section. So work hard and good luck.